And it's fun to be with you all. I always love meeting growers from other states and regions, and big admirer of everybody growing vegetables out there. So thanks a lot for having me. I'm gonna do kind of probably 30 to 40 minutes about my experience and overview on soil steaming in high tunnels. And the background is that I came at this from the perspective of trying to control chickweed in high tunnels, which for most folks growing greens in high tunnels, this becomes a problem eventually. And I did this research about five or 6 years ago. And in the meantime, I've been doing a lot of work on other high tunnel crops and high tunnel soils. And the more I learn about high tunnel soils, the more I realize we've been creating the perfect environment for chickweed to grow and developing other problems too in the long run in tunnels. And that is a whole other talk in itself. But I do want to say that high tunnels, we've created a situation with high residual nitrate. The winter season is really perfect for chickweed, and a neutral pH is what it really likes. So all of these things are building up this population of chickweed over multiple years. And hand weeding it is really, really difficult. It can root from the stems. It produces this incredible amount of seeds, 600 to 15,000 seeds per plant. And the seeds can be viable in the soil for up to 60 years. So once it explodes, it can be a really long-term problem. And I just want to say that it's really hard to control manually as a grower. I have a farm with 10 tunnels, and weeding it like this once it's out of hand is really not economical. So that's kind of how I arrived at this research, was from a pretty practical perspective on my own farm of wanting to manage chickweed, and watching people crawl around like that is not really how any of us farmers want to be managing things. And we've done lots of things, feeding it to our cows, and I'm pretty convinced that the seeds passing through them, and we're bringing it back in with their manure. So that's been a little bit of an eye-opener. And I've tried to feed it to children, doesn't work. So I'm appalled when I go into the co-op and I see it for sale for these for $40 a pound, just about. But really, we don't have the market for it. So I know people have tried to plunk it into salad mix. So what are we going to do about it? And this leads into this bigger question about other problems in the tunnel that we all are facing. Pathogens, damping off, other soil-borne diseases. And in essence, we're not managing high tunnel soils the way we manage field soils, with a lot of the tools in our toolbox, such as crop rotation, cover cropping, other ways we mitigate issues are just not really easy to do or implementable on high tunnels. So we're left grasping for other tools to manage things. And come to soil steaming. And I have this old book here, the UC System for Producing Healthy Container Grown Crops. It's from the 50s. It's a really fascinating book. I love looking at old agricultural texts because sometimes you're like, oh, they knew this stuff like 50, 60, 100 years ago. But this is kind of the Bible on soil sterilization. And the more I've gotten into this, the more I've realized there hasn't been a ton of work done since on this question. So this diagram here is from that original book, modified in the 70s, but hasn't changed much in these understandings of what gets killed at what temperatures. And the background on this is back when container grown and nursery crops came into kind of commercial production, people needed a sterilized soil. So they were looking at this from a complete obliteration of all organisms point of view, to grow crops in a container for sale or nursery production. So it's a little bit of a brain shift into where we might want to be with in-ground growing in high tunnels. So I just want to put that out there, that a lot of the literature is based on this concept of sterilization. And I would make the case that we're thinking more about pasteurization. So if you think about like the foods we eat and the differences there, there's a nuance to consider. So they were talking about 180 degrees back in these early days of soil steaming. And what that gets you, you can see on here, this 180 degrees Fahrenheit on the left, and you're wiping out pretty much everything except resistant weed seeds. And I was curious, what do you get at different temperatures? So at a fairly low temperature, 140 degrees Fahrenheit, you get most plant pathogenic fungi and bacteria. You get Pythium and Phytophthora, which are pretty common problems in tunnels. And a little bit above that, below 180 still, you're getting most weed seeds, whatever most means. So there's lots of different, nuances there. And people have tried solarization, they've tried tarping, they've tried anaerobic soil deinfestation. There's lots of other methodologies implemented in high tunnels that might have a space in this conversation, not just soil steaming. And this technology has really gotten a lot of momentum since 2005 when methyl bromide was phased out as part of the Montreal Protocol. And Europe, as in many things agricultural, is way ahead of us in the technology. And especially because they're growing in such huge tunnels and glass houses there, they've used it really effectively. And Steve Fenimore in California has really taken the lead on this in the US, primarily for strawberry growers in California who suddenly didn't have methyl bromide available to them. So he's brought steam technology to them for really the past 20 years. He's done amazing work. I have a lot of respect for what he's done. And you can see here this recent article in the No-Till Farmer. Wow, no-till growers might be talking about this. So they're using it on a field scale. And this is a whole other level of sophistication, cost, expense. I want to point out that one thing I've learned from Steve is that these moving mobile steamers are really cool because they're mixing the soil. And as I'll get into, the technology that I've explored and a lot of us have is really rudimentary in comparison. So as in many cases, like smaller diversified growers are pulling on kind of like decades old technology for for our production. So this is the steamer that I acquired back in 2021 to run this research project. And it's a used tobacco steamer. This photo is from David Pauck at Sassafras Creek Farm in Maryland. He's done a lot of great work on soil steaming, and I've learned a lot from him. So these are tobacco, used in the tobacco industry, primarily from Canada. So we got our steamer, and many people have, from a guy up in Canada who was retubing these, replacing these heat exchanger tubes. And he was trucking them down to the US and selling them to a lot of us smaller scale growers. And it's, it was like $5,000 or $6,000 for the whole thing. It's basically a giant tea kettle. It's a low pressure steamer. And, there's a lot of parts on it that needed replacement when we got ours, but fairly easy to work on and manage. So this is kind of where this all started, at least in the Northeast with growers I work with. And more recently, people have started buying new steamers, and sharing these cooperatively is a really neat concept. I was able to rent this from the Cheshire County in New Hampshire, not too far away. They were running a lease program, so they bought this as a conservation district. They're leasing it out, and there's lots of other groups emerging doing this work, which is a nice way to share something that costs, I think this machine is about $30,000. So not really cost effective for my farm, but shared among many growers, it could make sense. This one, technology is not super different, but is a lot easier to run. The big difference with that first steamer is you kind of have to be watching it the whole time. So you're kind of hanging out for like an hour and a half, just, making sure nothing goes completely wrong. Whereas this one, you can kind of set it, forget it, come back. So that's kind of, there's obviously like this company, Sioux Steamer, is the main brand in the US, and they have lots of different scales and sizes. I know a grower here who bought one that could do 2 houses at a time. So depending on what scale you're at, there's lots of options out there. The method we're doing is called sheet steaming. So the concept is fairly simple. You're running steam along the surface of the soil, and it penetrates to a certain depth. And it's important to recognize that depending on what problem you're identifying in your soil, thinking about the depth at which that problem occurs is what you're targeting that temperature at. And then the temperature varies, so if you're going down to 2 inches, which is kind of common for weed seed problems, the temperature below that is also going to heat up, and the temperature above it will get even hotter. So it's a pretty like crude technology, but that's kind of the concept, is you're really getting your target at the depth you want. The machine we are using steams about 600 square feet. The other thing is, again, going back to this book from the 50s, is understanding that the soil, you're penetrating the soil with the steam. So the more clods, clumps, I have a clay soil here, It's a little bit anti our no-till philosophy. If you're a no-till person, that any clod is going to be impenetrable or less penetrable and a refuge or a reservoir for any of the problems you're trying to eliminate. So what you're aiming for is a fairly pulverized or at least homogeneous soil so that the steam can penetrate uniformly across it. Hopefully that makes sense. It was really interesting reading this old book because they pull a lot on like Alaska and like how they're extracting oil and all these like science that they've used from those days. So I'm going to walk through really quickly for folks who haven't done this before the steps, just so you get a sense of what the actual work is. So you want to prepare your beds as if you're about to plant them. And this, for most of us, we're doing this in the fall, but some people, if you're doing it before tomatoes, this would be a springtime activity. So, and this is Bruce Worcester from Piccadilly Farm in New Hampshire. He's done a lot of great work on this. So you have this thing called the steam sock. It's a canvas. Well, there's lots of different materials. We used a canvas grommeted sock. You lay that out on the bed, and then you have this tarp, and you can get a special steam tarp, or you can use greenhouse plastic, and you want to secure it so the steam doesn't escape. So we had Bruce developed the system with buckets and chains, and you kind of just layer out the chain from the buckets. And then you leave it for about 30 minutes at temperature. If you're just starting the steamer for the first time, it takes like 30 minutes to get to temperature, and then you leave it for 30 minutes. And in my estimation, once you've like fussed with everything, it's about a 3-hour project to do 600 square feet. So for an entire tunnel, it's, essentially a full day when all is said and done. But at the end, we have found weed-free soil. So this is on Bruce's farm again. And this is some beds he steamed previously and planted right into. This is kind of early fall and no weed pressure. So I've mentioned some of the benefits. To review those. It's weed and pathogen control, no hand weeding, and no chemicals if you were someone inclined towards those. And then the other piece of the puzzle, and this was like highly anecdotal when I started doing this, but there's a lot of science to back it up, is you get this flush of nutrients. What's really happening is you're killing the nitrifying bacteria and you're killing microbes. And so all of that like stored available nutrients become available to the crops very quickly. So it's not like a great long-term soil health strategy. So just to recognize that the effect that people see with this like flush of growth is really related to knocking back this bacterial population. And I'll talk about that a little bit more in a second. But what are the drawbacks and concerns? And I think for one of the drivers of this research, besides my own personal chickweed issues, was grower after grower after grower saying, well, doesn't that kill everything in the soil? Isn't that a terrible thing to do? And we've got this huge interest in soil health. So I can't tell you how many times I got this question if soil steaming ever came up in a meeting. So, well, what is the problem with it? And I want to posit like kind of in the forefront of the conversation, the way I've kind of thought about this myself is that tunnels are a very different environment than our field growing. They're a little more contained, so any environmental effects from, in Vermont, we've got lots of concerns about high phosphorus. Any detrimental soil health activities are a little more contained in a tunnel. So I think about it more purely from a production standpoint, like how we're managing the soil health, and less like a broader environmental consequence within certain boundaries. So again, I think we've created some unique scenarios in high tunnel in-ground growing that require unique solutions. So I'm diving into the research I did. Again, this was quite a few years ago, like 2021, 2022. And my goal was to really identify like what was the lower temperature at which we could control chickweed, because that was the main concern of most of the growers that I work with and on my own farm. What could we like do with the least cost and fuel expended? So the first year I looked at 3 temperatures, 120, 140, and then 160 to 180, trying to get up to 180 for that third temperature. And you can see right off the bat, 120 didn't have great control, 140 looks pretty good. And then a little further into, this is direct seeded spinach. Again, you can see at 140, 6 weeks after seeding, things look great. And that was the chickweed population that I was faced with. So it's a huge difference. And you can see that it was very quickly obvious that this was a nice practice for us. And then again, at these three different temperatures, you can see not just that the weed control is better at 160, but that flush of growth really took off. So that's again, this like release of the nitrifying bacteria releasing this huge flush of nitrogen to the crops. Now, I had heard from many growers that they steam every single year. I'd heard from some growers, oh, we steam for 3 years and then we don't steam for 3 years. And I was curious, like, is this something like you do every year? Because, like, man, you got to do like a day per tunnel. I've got 10 tunnels at a time of year when I'm trying to flip everything really quickly. What does this really entail if this is a practice we're going to take on? And is there a way to like kind of ease into it? So a year later, we did see populations come back. I was gathering data that it was like 30 to 40% of the previous pressure, but still pretty bad. And you can see that you create some reservoirs for weed seed if you don't have a super tidy, clean tunnel. So on the edges of our tunnels, it's hard to achieve that temperature on the edges. The temperature under the tarp is really uneven too. So we had like 10 temperature probes under there and they were all reading kind of differently. Again, you're just dropping that sock under the surface and hoping that it penetrates evenly, and it's not as even as you would like it to be. And you can see that I caused some kind of relationship problems with my spouse that I farm with by leaving a control in my research, because that was like the reservoir for continued chickweed problems. So this control on the left was in 2020, and you can see even in 2022 that seed bank is really quite high. So just to take home that if you're trying to steam, just like any weed seed bank issues, you really don't want to leave any reservoir behind. I was curious about the effect on damping off because in the past this had been a problem for us, and I didn't even realize how much of a problem it was. So on the left was the steamed bed, and on the right was the steamed bed. And when I quantified a couple treatment areas, and we were losing 40% of our seeds to damping off. It's a pretty huge loss. And you can see that the seeding rate we were using was really kind of calibrated for that loss. And once I steamed, we almost had too heavy of a population. I was also lucky enough to connect with some researchers. Dr. Anna Teston at Ohio State was doing some research. She's with the USDA ARS, and her team was looking at high tunnel soils, high tunnel tomato pathogens. And I was like, hey, can I send in samples from steamed versus unsteamed tunnels to see what you find? And sure enough, as we kind of hope / expect, the steamed tunnels showed much lower incidences of root rots, root knot nematode, and kind of all pathogens. And this was interesting to me because I didn't even know we had root knot nematode. I hadn't seen signs of it on our tomato roots, but turns out we have had it in our unsteamed tunnels, and the steaming was really taking good care of it. In the unsteamed tunnels, they detected all pathogens. So again, we've got this pretty high background level in these tunnels. I don't know if they're causing economic problems. We're primarily focused on tomatoes on my farm. So I'm not saying we were feeling like we had a huge issue, but I was surprised that the tests came back with these results. Now, this bigger question that everybody was asking me is, what does this do to soil health? And as I'm sure you all know, soil health is a really, really hard thing to quantify. And there's so much work being done on this right now. So many different ways to ask the question. I had 2 years, just under 2 years to do this study, which is like 2 short growing seasons. And I wanted kind of a quick assessment of how to measure soil health. So I talked to a soil ecologist, Dr. Deb Nair at UVM, and she suggested using these BioLog ecoplates, which are used in a lot of different scenarios for measuring, in water quality, in like all over in environmental science. Folks have been using these. I hadn't used them before, but her case was you get 2 measures from this, and they're pretty broad, but this is like kind of the big, kind of a arching research project on this. So the 2 things you can learn from these plates, they have carbon substrates on the plate. So what you do is you take the soil and you add the soil or the microbial biomass from the soil into the plates and see two things. One is how much they consume of the carbon substrates, and that is a measure of the size of the population. And then you see the diversity of substrates that they consume, which indicates the diversity of the population. So you're getting these two indications from these plates, population size and population diversity. And I was taking these plate measures every couple of weeks after steaming to see what we found. And what we found is that we killed a lot of the microbes in the soil. So as you would expect, we are really wiping out that top 2 inches. And we didn't see a huge difference in the temperature variations here, which kind of tracks with that first chart I showed. You know, even at 120 degrees, you're killing quite a bit of the population. So what I couldn't see is who we were killing, but the take home was like, wow, you get a really, really fast knockback with the soil steaming. And the x-axis on this graph is number of weeks after steaming. So you can see at 52 weeks, we're almost back up to normal. Now within that, there's all these other variables, right? You've got soil temperature, you've got the crops growing, you've got moisture. So it's not a perfect experiment. It was a very I only did 2 or 3 years of samples, but this kind of lines up with what we have read in the literature as well. Now the diversity, at first I was like, whoa, is this wrong? This is crazy. So we actually saw kind of a bump in diversity immediately after steaming. And upon further investigation, you realize that this is because there's probably more food available. You're breaking apart killing off a lot of those bacteria. There's like a massive food source. So it's like you've like harvested all of your crops and just left them on the surface, and they're going to rot, but all the predators are going to come in and eat them. So it's a kind of like clear cutting a forest. What grows back quickly, it might not be what you want, but it's a pretty big diversity of species that might come back in. Not always, but in any case, that again is kind of been replicated in the literature as well. So again, you can't see who's there, if that diversity is good or bad, but there was a lot of food available after steaming. And this one actually surprised me a lot at first. I was like, oh, I thought the nitrate would increase because that's what people are seeing is this flush in growth. What I've learned since this study is what I really should have been measuring was soil nitrate and ammonium, because you're killing the soil nitrifying bacteria with steaming. So what's actually available is ammonium, and what the crops are taking up is ammonium, which is not their favorite form of nitrogen, but they can use it in most situations. And that's causing that burst of growth. So that's been kind of a moment for me. It's like, well, this was a very confusing graph. I wasn't sure why the nitrate wasn't increasing when we were seeing these like super green like flushes of growth. And now we can say that was because the nitrifiers were gone, most likely. And just to show that there's, again, not a lot of work been done on this, but some folks have found similar things. You know, the take homes are that the microbial biomass is decreasing. Fungi are pretty well knocked out from other studies, and the nitrifying bacteria as well. And then as a result, you have this accumulation of NH4N, which is that ammonium nitrogen, which under normal circumstances is converted to nitrate, which is the favorable form for, excuse me, for vegetable crops to take up. And then some other things that people have found is this enhanced solubility of salts, and some folks have found an increase in pH over multiple steaming rounds. So some of those things I think are important to kind of flag as concerns that are already happening in tunnels. We see an increase in pH over many years, at least here in the region I'm in. Insoluble salts are an issue. So if steaming's gonna exacerbate those problems, it's something to keep an eye on. I also wanted to know how much this cost, because it seemed incredibly expensive, like buying a steamer, doing all the work, buying the fuel. So I wanted to put some numbers to this practice. These numbers are a couple of years old, and you know things are changing all the time, especially with fuel. And the important number here to keep your eye on is the cost of that steamer. Remember, I bought that like junky steamer from Canada that does require some maintenance. This would all look very differently if I had that $30,000 steamer plugged into this chart. So again, this math is based on a kind of rinky-dink piece of equipment, but it it worked. So what we found was that the total cost per tunnel was about $700 for a average size 2,700 square foot tunnel. The thing that threw me a bit was how much fuel we were using. So 55 gallons per tunnel felt like a lot, especially again, we have 10 tunnels on my farm. That's, maybe not such a crazy expense in terms of cost, but in terms of fuel, it felt like more than we used for a lot of other activities. So something that kind of was, I guess, kind of challenging philosophically for us. I also wanted to kind of compare the value versus like a hand weed if we paid someone to hand weed. So per square foot, this is what I came to. Again, this was that same treatment area that had that Pythium difference. So the stand is a lot worse, a lot weaker stand. And the weeding, once I weeded out the chickweed, I came up to about $3.20 per square foot versus $8.50 per square foot of crop value. My colleague Chris Callahan and I came up with this calculator that's online. I can send Chris the link to this afterwards. It's just an Excel sheet, but you can plug in the numbers for your bed size, your target temperature, your soil type. These are all factors that are really important. And then these things down here, your nozzle sizing, your burner, boiler efficiency, these are all important factors in actually getting the steam generator to work. And especially if you have one of these older tobacco ones, this was very useful for us. We had to replace our nozzle. So we did have to dig into this to get our steamer working. And it's interesting to understand. And you can estimate how much fuel you anticipate using with this. So I did work with several growers here in Vermont who use it. There's a couple farms that swear by it. They do it every single year. They've got it really dialed down, and it pays for them to do this. They rely heavily on winter greens. And these are kind of just the quotes that I got from them, but it works, right? You get a really clean house with great greens. If you're mechanically harvesting, it's pretty essential. But the downside was this ton of time and fuel. And it's at a hard time of year for a lot of people. So feeling kind of compromised about that and not sure if the benefits were worth it. And then I've worked with growers who are targeting a problem, right? So they say, well, I've got nematodes, or I've got, dahlia tubers, or, struggling with fusarium. Those targeted problems, I think, are a great use of the steam technology. So coming in to wipe out a problem, it might not be an every year thing, but a couple years, renting a steamer is a great opportunity there. And so for this one grower, they were like, wow, it was a huge effort, but I think they knocked back the nematodes. So it kind of got them to where they wanted to be. So my kind of take homes from this are, again, it does work really well. It's increasing revenue and reduces yield losses to chickweed and to other pathogens. And coming in with a high population of chickweed to start with, it's not a long-term solution. So full transparency, we haven't steamed since 2023 on my farm. And the chickweed is still fairly tolerable, but we're getting to the point where I'm like, okay, I guess if we really want to hit this, we should do it now to get it back to a tolerable level. We do see this impressive reduction in damping off. And I think these longer term concerns about the soil health are manageable. And the recommendations, I have made and I continue to make are to come back in, with as many living materials as you can, compost, any like kind of oovy groovy amendments that you think might help, like foliar feeds or soil enhancing organisms. I think this is the time to use them. The proven ones are like Root Shield, I think works great, and Actinovate, things that you really feel confident in helping your roots be strong. Although Pythium gets knocked back by this, it's also going to be the first thing to come back in and colonize. So the analogy that sits in my head is using an antibiotic in my own personal health. If I have something going on, the first thing I want to start eating again is like yogurt and sauerkraut and living things that will help my body kind of recalibrate after such an event. So that's kind of my take on it and what I've been recommending to people. And then I am curious about technology improvements. This sheet steaming is pretty crude, pretty time intensive. And, there's been a little bit of kind of like conversation, would somebody ever make one of these mobile steaming units? And what Steve Fenimore really pointed out is that like a little bit of activity with tillage or soil mixing on the surface could really help that steam penetrate more evenly and really get you the result you want while moving through a field or a tunnel. So I think I'm going to stop there.